Hello students, my name is Parth Kumar Singh and I am an alumnus of IIT Jodhpur. Today we are going to understand a very interesting question that was asked in NEST 2024 session 1. So basically in this question, the important thing is that they have asked about an intramolecular reaction which you are not clearly used to, because in NCERT there is not much about this particular reaction. So basically what they are saying, an intramolecular aldol reaction of P in presence of dilute NaOH yields a mixture of aldol reaction products. So basically this is your substrate on which you have to apply the concept of aldol reaction. Now we know that substantially this compound can give a variety of aldol products because of the presence of variety of alpha hydrogens available here, right? So now what they are saying, that one of the products that can be formed through the aldol reaction via this substrate is which one basically. So basically there are 4 set of compounds and either one of them is basically feasible while you try to make it from the aldol reaction of this particular compound. So now since we know that this particular compound has so many alpha hydrogens, like this one, like one from this carbon, like one from this carbon, right? So many alpha hydrogens and correspondingly 2 carbonyls. So there is a variety of attack that are possible and a variety of cyclic structures that are eventually possible through this type of aldol reaction basically. Now we have to guess only one. So it becomes really difficult to go for each and every type of products given, analyze them whether they are forming or not. The right approach in this type of question is basically you follow your basic approach, what you know, right? And then see if it is forming or not. You have to select any one of it because it is a MCQ, so you have to use your mind also. Otherwise this question will be a very hectic question to solve. So in this question what we will do, see, now analyze these, right? So let's suppose that what you have so far understood about aldol reaction is that the ketones are relatively less electrophilic as compared to aldehydes. Because of the presence of one extra CH3, there is a substantial plus I that decreases the electrophilicity of the carbonyls CO. So the first choice is that we attack the hydrogen from this particular ketone onto the carbonyl of this CHO, because this CHOs tend to be more electrophilic. So let's give it a chance to be electrophilic here. So what we will assume, that let's say this OH minus comes and abstracts proton from here and forms an enolate like this. Now we know, let me just open this up. Now we know that this will be in a resonance of this particular enol form, right? We know that. And then obviously this is basically O minus, right? So these two actually plays with each other, right? So the major reactivity is through this one. So what will happen, actually this will come here back and this anion will now attack on the electrophilic carbon of this CO group. So making a, now you can analyze that if this carbon is attached to this one, how many number of rings we have, means how many membered ring we are forming actually. So just count it. We are forming a 1, 2, 3, 4, 5. So 5 membered ring. So what we will draw, a basic skeleton of a 6 membered ring. This is basically nothing to do with the main substrate. Keep it as it is and draw a 5 membered ring now and number it from here, right? 1, this carbon attached from the benzene ring was first. Second is basically this one, third, fourth and fifth. Now see, on the very 5th carbon you will have an O minus that will eventually turn into an OH group that we know, right? Because the basic product that we get in aldol before the elimination part is basically an alcohol. So here we will get an OH, and this COCH3 group that was lying on the or attached on the first carbon will be placed like this. So luckily, following the simple rule of the reactivity pattern between aldehydes and ketones, we came across the correct answer somehow, that this will form. You are sure shot that this compound can form through this, and this is what is given in one of the options, that is this one, where it is this one. See, same, right? 6-membered ring, 6-membered ring, then on the then attached a fused 5-membered ring, and then on the first carbon you have a COCH3, and on the next carbon you have a OH group. So basically this is what you will get after doing aldol of this particular substrate. This is one of those products that they were asking. So likewise, if this kind of a question comes again in the exam, you may have so many of the confusions, like which alpha hydrogen we need to be abstract first, right, and where to attack. So many possibilities, like this wala C minus can also attack here, right, and this C minus can also attack there. So many possibilities, I know, but you will follow the simple fundamentals step by step. For example, we just noticed here that out of ketone and aldehyde, we know that aldehyde have substantial electrophilicity. So we will try to give the chance of being electrophilic to aldehyde first, and out of this and this proton, we subtracted or basically abstracted the proton from this particular carbon with a reason. The reason is that we know that if we abstracted carbon, hydrogen from this carbon, it will make a 1, 2, 3, 4, 5, 6 and 7-membered ring. Otherwise, if we abstracted, just like we did, abstracted proton from this carbon, we ended up in a 5-membered ring, and we know as per the steric hindrance rule, we know that the stability of a 5-membered ring is relatively more than as compared to the stability of a 7-membered ring. So that is why we have chosen this proton over this proton. However, both has the possibility. So this is how, following the right fundamentals, we ended up to the right product. So this is how this question was meant to be done. And if you like this type of videos, you can always comment down below. Thank you.